Hi students, so in this video we'll be continuing with our previous video of electrochemical cell and we will mostly study about your salt bridge, right? So just a quick recap of what we studied. We studied about electrochemical cell, right? What is an electrochemical cell? Electrochemical cell is something which converts your chemical energy into your electrical energy. That's our main goal, to produce the electricity. How does this happen? We take two components. We take two things, right? Two compartments basically. And in these two compartments, two rods are immersed. One is your zinc rod, the other one is your copper rod. So there is a left hand side, there is a right hand side. I told you a trick to remember things. Lone. Left side oxidation, anode negative. So left side is your anode side and your right side is your cathode side. So in left side, what is happening? You are taking a zinc rod which is immersed in your ZnSO4 solution, and your zinc is undergoing oxidation. So zinc undergoes oxidation to give you Zn2 plus 2 electrons. So you know the Zn2 plus is going into the solution, and these two electrons are coming and traveling through the other end and going to the cathodic part, so that your copper here, right side has copper along with your CuSO4 solution. So in right side, what is happening? Your copper ion is accepting the electrons to give you copper, and that's how your electricity is getting generated, right? But there is a very big problem here. What is the problem here? You know that your zinc sulfate solution was made up of zinc ions and sulfate ions, right? Similarly, your copper sulfate solution is made up of Cu2 plus and SO4 2 minus ion, right? Now, what the problem is, after the oxidation of zinc, you are getting lot of zinc ions from the rod, right? Lot of Zn2 plus ion is coming in the solution. So basically what's happening, like already zinc ions are present in the solution, lot of zinc ions are accumulating, because of which it is now becoming a positive solution. This is now becoming a positive solution, understood? Our solution was ZnSO4 made up of zinc ions and sulfate ions. The zinc rod is undergoing oxidation to give you Zn2 plus electrons. Electrons are traveling to the other apparatus, but your zinc ions are increasing, right? Zinc ion is going in the solution. So basically lot of Zn2 plus ions in the solution, because of which the solution is actually becoming positive. This is what is happening on the left hand side. But what is happening on the right hand side? Your Cu2 plus is accepting, like Cu2 plus from here and from the rod is accepting electrons to give you copper, right? Cu2 plus is giving you Cu2 plus from the solution is getting sticked here. So in the solution you have lot of SO4 2 minus ion remaining, because all the copper ions are accepting electrons to give you copper. So lot of SO4 2 minus ions in the solution. Because of this, the solution is actually becoming negative. The solution is becoming negative. So this solution is becoming positive, this solution is becoming negative. So this solution, because it is becoming lot of positive, this is preventing the outward flow of electron. This is telling electron, please don't go outside. We are positives, you remain with us. So it is, this one is preventing the outward flow of electrons. This is preventing the outward flow of electrons. And what is this one doing? This one is preventing, because this solution is becoming lot of negative. This is preventing the inward flow of electron. This is preventing the inward flow of electron. Because why electricity happens? Electricity happens because of the flow of electrons. Now because of this problem, there is no electricity getting generated, right? So there is only one solution, and the solution name is salt bridge. The solution name is salt bridge. Now what is a salt bridge? Salt bridge is basically a U-shaped, inverted U-shaped bridge. Inverted U-shaped bridge, and this is filled with an inert electrolyte. This is filled with a inert electrolyte, and this inert electrolyte can be your KCl, your K2SO4, your KNO3, your NH4SCl. It is filled with a inert electrolyte in agar-agar powder so that it becomes semi-solid, semi-liquid kind of agar-agar, so that the paste becomes little thick. That's why the agar-agar powder is added. So the salt bridge is an inverted U-shaped bridge which contains an inert electrolyte with agar-agar powder so that this becomes strong enough. So you guys know what was happening on the left hand side and the right hand side, right? In left hand side, you were getting lot of positive things, positive solution. You were getting positive solution, and on the right hand side you were getting negative solution. Because of this, you were not able to produce electricity. So what will happen? You have a salt bridge, it contains inert electrolyte. Inert electrolyte means it will not react with anything. This one will not react with anything. So supposingly I am taking inert electrolyte as KCl. So it has K plus and Cl minus ions. So naturally Cl minus ion will go here, K plus ion will go here to neutralize the solution, and the problem will be solved. Okay. So very easy functions of salt bridge. It maintains the electrical neutrality of the cell. Functions, what are the functions? It maintains the electrical neutrality of the cell. Electrical neutrality of the cell. And what it is doing, it completes the circuit by allowing the flow of electrons. By allowing the flow of electrons. And the third very important thing is, it minimizes the liquid-liquid junction potential. It minimizes the liquid-liquid junction potential. Now, what is that potential? You guys were knowing that there were two apparatus. Like in reality, it is actually one apparatus only. Just to differentiate it, we just show it in a two different apparatus. Now, this side, on the left-hand side, you were getting lot of positive ions, right? And on the right-hand side, you were getting lot of negative ions. So because of this positive and negative ion, there is a thing called as liquid-liquid junction potential, which stops the current to flow. So because of the presence of your salt bridge containing inert electrolyte, which minimizes the charge, so it minimizes the liquid-liquid junction potential so that your electrons can now flow easily and your electricity is being generated. Okay. So this is all about your salt bridge. Now there are some conditions for salt bridge which you should remember. You have some conditions for salt bridge. The first condition is the electrolyte should be inert, because what if it reacts with something and produces something else? What if it produces some insoluble things? So first condition is the electrolyte should be inert. The first condition is electrolyte should be inert. Like for example, if you take KCl, in KCl what are you getting? K plus and Cl minus ions. Now these ions do not react with any of the half cells, so we are safe here. But there is a catch. But what happens? Zinc reacts with Cl minus. Zinc is reacting with Cl minus. So like zinc is reacting with Cl minus ion to give you ZnCl2. But this is also not a problem. Why? Because ZnCl2 will be a soluble salt and it will again break down into Zn2 plus Cl minus. Okay, so first condition of any electrolyte is condition for salt bridges, that your electrolyte should be inert. If it is not inert, then that's a problem. Like for example, if you are taking a silver electrode, now silver will react with chlorine to give you AgCl, which is actually a precipitate. You cannot use KCl here wherever you have Ag electrode, because it will form a PPT and it will form hindrance in your reaction. The second condition, very easy condition, that all the ions whatever you are taking in your electrolyte should have good mobility. They should have your good mobility, or just say equal mobility. Both K and Cl should be managing well. Good mobility and equal mobility. These are the basically two conditions which you need for your electrolyte, right? So this was all about your salt bridge. You need salt bridge for three conditions, so that they minimizes the liquid-liquid junction potential, they don't break the circuit, and they maintain the electrical neutrality of the cell. Now next topic which we need to study is your cell representation. I think so we will study this better in the next topic. So till then, please revise the topics. Thank you so much.